Langley Research Center is the oldest of NASA's field centers, located in Hampton, Virginia, United States. It directly borders Poquoson, Virginia and Langley Field. LARC focuses primarily on aeronautical research. Though the Apollo lunar lander was flight tested at the facility and a number of high-profile space missions have been planned and designed on site. Established in 1917 by the National Advisory Committee for Aeronautics, the center currently devotes two-thirds of its programs to aeronautics, and the rest to space. LARC researchers use more than 40 wind tunnels to study improved aircraft and spacecraft safety, performance, and efficiency. Between 1958 and 1963, when NASA started Project Mercury, LARC served as the main office of the Space Task Group, with the office being transferred to the Manned Spacecraft Center in Houston in 1962-63. The current director is David E. Bowles. History. In 1917, less than 3 years after it was created, the NACA established Langley Memorial Aeronautical Laboratory on Langley Field. Both Langley Field and the Langley Laboratory are named for aviation pioneer Samuel Pierpont Langley. The Aviation Section, U.S. Signal Corps had established a base there earlier that same year. The first research facilities were in place and aeronautical research was started by 1920. Initially, the laboratory included 4 researchers and 11 technicians. Langley Field and NACA began parallel growth as air power proved its utility during World War I. The center was originally established to explore the field of aerodynamic research involving airframe and propulsion engine design and performance. In 1934, the world's largest wind tunnel at that time was constructed at Langley Field with a 30 × 60-foot test section, which was large enough to test full-scale aircraft, one of the first wind tunnels able to do this. Early in 1945, the center expanded to include rocket research, leading to the establishment of a flight station at Wallops Island, Virginia. A further expansion of the research program permitted Langley Research Center to orbit payloads, starting with NASA's Explorer 9 balloon satellite in mid-February of 1961. As rocket research grew, aeronautics research continued to expand and played an important part when subsonic flight was advanced and supersonic and hypersonic flight were introduced. Langley Research Center can claim many historic firsts, some of which have proven to be revolutionary scientific breakthroughs. These accomplishments include the development of the concept of research aircraft leading to supersonic flight, the world's first transonic wind tunnels, the lunar landing facility providing the simulation of lunar gravity, and the Viking program for Mars exploration. Also, the grooving of aircraft runways was developed at Langley Research Center, which permits better grip by aircraft tires to the surface than a traditional smooth surface was developed at Langley. This grooving is now the international standard for all runways around the world. Aeronautics. Langley Research Center performs critical research on aeronautics, including wake vortex behavior, fixed-wing aircraft, rotary-wing aircraft, air safety, human factors and aerospace engineering. LARC supported the design and testing of the hypersonic X-43, which achieved a world speed record of Mach 9.6. LARC assisted the NTSB in the investigation of the crash of American Airlines Flight 587. Work began in July 2011 to remove the 1940s-era 16-feet transonic wind tunnel. The facility supported development and propulsion integration research for many military aircraft, including all fighters since 1960 but had been inactive since 2004. Langley retained transonic wind tunnel testing capabilities facilities in the National Transonic Facility, a high-pressure, cryogenically cooled 8.2 feet closed-loop wind tunnel. Fabrication research and development. Electron beam freeform fabrication. The EBF cubed process produces structural metallic parts with immense strength, and are useful in performing repairs in remote locations. Additionally, the ability to build functionally graded, unitized parts directly from CAD data offers enhanced performance in numerous applications. Recently, LaRC has become home to this new type of machining process, which is used by their new room-sized electron-emitting device, which uses a high-frequency 42 kilowatts X-ray-emitting electron gun, which quickly melts either aluminum or titanium wire into the desired three-dimensional metallic parts with a material strength comparable to that of wrought products. The machine's deposition rate is 150 in cubed H, equivalent to its plastic fabricating counterpart. Metallic parts are also built directly from CAD without molds or tools, leaving the end product with absolutely no porosity. Other properties include 6-axis positioning, heated or cooled platen, 1 × 10⁻⁶ torr vacuum capability, 72 × 24 × 24-inch build envelope, power efficiency in excess of 90%, near 100% feedstock efficiency, can deposit reflective materials not processable with lasers, potential portable EBF cubed system, potential fabrication and repair from the plants to the planets. Research assistance for developing large-scale fabrication in space. Overall, electron beam freeform fabrication is a layer additive technique that offers potential for improvements in cost, weight, and performance to enhance mission success for aircraft launch vehicles and spacecraft. Plastic fabrication. LaRC also houses a large collection of various, inexpensive plastic reformation machines. These machines are generally very critical in the freeform fabrication department for faster timing, better precision, and larger quantities of low-cost toy, model, and industrial plastic parts. The fabrication of plastic parts is not all that dissimilar to the EBF cubed process, except the melting apparatus is a thin, grated heating element. But other than that they are quite similar, e.g., they are both run completely by CAD data and deal with various freeform fabrication of raw materials. Plastic reformation machines have also come to the interest of graphical artists, opening a whole new world of bringing their masterpieces to life, all with a flick of a switch, so to speak. Astronautics Moon. Since the start of Project Gemini, Langley was a center for training of rendezvous in space. In 1965, Langley opened the Lunar Landing Research Facility for simulations of moon landings with a mock Apollo lunar module suspended from a gantry over a simulated lunar landscape. There was experimental work on some lunar landing research vehicles. Mars. Langley Research Center supported NASA's mission by designing a spacecraft for a Mars landing. Earth Science. Langley Research Center conducts Earth science research to support NASA's mission. Awards. LRC scientists and engineers have won the Collier Trophy 5 times. In 1929 for the development of low-drag cowling for radial air-cooled aircraft engines, 1946 to Lewis A. Rodit, Lawrence D. Bell and Chuck Yeager for the development of an efficient wing de-icing system, 1947 to John Stack of the then Langley Memorial Aeronautical Laboratory for research to determine the physical laws affecting supersonic flight. Also shared in this trophy for their work on supersonic flight, 1951, to John Stack for the development and use of the slotted throat wind tunnel, 1954 Richard T.